Okay, we are back. This is Math 200. We are looking at section 2.5 from the note packet. That is page 12. Turn on C3PO's eyes. And let's get started. So, back in the day, we worked with inequalities. Inequalities are when you have a greater than or less than sign, or greater than or equal to sign, or not equal to sign. Equality, of course, is an equal to sign. Equalities are pretty boring to graph. It's just a dot on a number line if it's equal to. So if it's x equals 3, you just go to 3 and put a dot there, and that's it. So we don't normally graph equations with an equal sign. Inequalities, however, is an infinite set. And so x such that x is greater than or equal to 2. This straight up and down line means such that, the squiggly lines means the set. So if I were to read this out loud, it would be the set that contains x such that x is greater than or equal to 2. All right? What that looks like on a number line. And now you can do these above the number line, like float it above the number line so it's easier to see. I'll just do it on the number line. I'll use a different color. All right. And so when it's greater than or equal to, that is a bracket. The way that I memorized that when I first learned it was, look, a bracket sort of makes an equal to sign if you cover up the brackety part, that part, the long part. It's a big old equals to sign. Equals. Greater than or equal to, less than or equal to, use a bracket. If it's a greater than or less than sign, use a parenthesis. This would be the same as when you did the filled in circle or the open circle. The open circle was for greater than or less than. That was a boundary. The closed circle is inclusive. It includes the number and goes on. Instead of a closed circle, though, we're going to use a bracket. Instead of an open circle, we're going to use a parenthesis. So again, if I read this aloud, it is x is greater than or equal to 2. So that means 2 and higher. What that looks like in interval notation is sort of like a graph without doing a graph. So look, it starts at 2 with a bracket. That means 2 inclusive. It includes the 2. And then it's going off to the right forever. That's positive infinity. You don't have to put the plus in front of it. If there's not anything in front of it, it's positive infinity. If there's a negative in front of it, it's negative infinity. Here's the thing. Infinity never gets a bracket. It always gets a parenthesis because it can't actually be that number. Infinity isn't a number. It's the concept that numbers never end. They go on forever. And so, never a bracket. Always a parenthesis on the infinities. Okay? Let's do some more. Okay, so the set that contains x such that x is less than -1. So here we go again. Remember, negative numbers, as you get larger, they get larger as you go to the left from 0. So that's -1, that's -2, that's -3. They're not actually getting larger. They are smaller. You know, I'd rather owe somebody $1 than owe them $3. So $1 is a larger amount. But as the absolute value gets larger as you leave 0. On the positive, we live in the positive, so that always makes sense. The farther from 0 on this positive number line, the larger the number. The farther from 0 on this negative number line, the smaller the number. All right? So we got parenthesis on -1 and then shaded left. So now think about if you ran into some stuffy professor that said, yeah, we're not doing little pictures. I want that in interval notation. So then you'd say, okay, I want a picture without the picture. So think about this is going forever. It's negative 100, negative 1,000, negative 10 billion, okay? So that means negative infinity is what's happening here. And then it comes to an abrupt halt at negative 1 and nothing else from that sign. So it's from negative infinity to negative 1. It's a less than sign, so it doesn't include the negative 1. That's a parenthesis. Infinities, positives or negatives, always get parentheses. So do you see how this is the exact same as that? It's the same representation. It's negative infinity up to negative 1. This, it started at 2 and went forever positive, 2 to positive infinity. Let's look at this. This is called a compound inequality. So we've got 1, 2, 3. All right. We have a bracket on the 3 and a parenthesis, because it's just a less than sign, on the 0.5. And then shaded in between. Okie dokie. Let's make sure everybody can see those okay. All right. And then if I want to do, this one translates the best in interval notation from the graph. We got 0.5 not inclusive to 3 inclusive. All right. Lovely, lovely. Let's do page 12. Oh, wait, that was page 12. Let's do page 13. All right, so now they want us to solve the inequality and then graph and then do the interval notation. Okay, so if this were an equals to sign, we'd isolate the variable. We'd want x equals. It's a less than sign, so we're going to do all the same things. Isolate the variable. We got x is less than 7. And so now, what do they all want? They want the graph and they want interval notation. So just like what we did there. So the graph and then interval notation. So what do we got? We got x is less than 7. So 0, 1, 2, 3, 4, 5, 6, 7. And that's going to be a parenthesis. And then it's shaded to the left. All right, and so that's negative infinity up to 7, not inclusive. We've got, 3x plus 4 is greater than or equal to 2x minus 6. So a few more steps. So it just treat it like it was an equals to sign. If that was an equals to sign, what would I do? I would subtract 2x from both sides, and then I would subtract 4 from both sides, and then I would divide by whatever number is in front of the x. So we'll do minus 2x, and that wipes it off of that side. And then minus 4. And since 3x minus 2x is 1x, we already ticked that box. X is greater than or equal to negative 10. All right, so let's graph that. And then do the interval notation. So we got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's negative 10, and now it is x is greater than or equal to. So that is a bracket, and then shaded right. And what would that look like in interval notation? That is the answer without making a graph. That would be negative 10 to infinity, and the negative 10 is inclusive, so you put the bracket on that, and then infinities always get the parentheses. Oops, gravity just worked there. All right. Okay, let's go on to some more interesting things. Oh, so before we do these, when you divide or multiply by a negative number. So working with inequalities, just like working with equations when there's an equals to sign there, except there's one extra rule. if you ever divide or multiply by a negative number, you have to reverse the inequality sign. So if it was greater than or equal to, it's now less than or equal to. If it was less than, it's now greater than. Only if you multiply or divide by a negative. And why is that? Well, because everything works the opposite in negative land. Think about this. If I had a true statement, 5 is greater than 3, right? 5 is greater than 3. If I divide both of those by -1, I got -5 and I got -3, and things in negative land work exactly the opposite that they do in positive land. So in order for this to be true, I'd have to flip the sign. -5 is less than -3. All right? So that's why we have to do that. Let's do some problems. 1/4 x less than or equal to 3/2. They want me to solve it, graph it, do the interval notation, and do the set notation. So, the graph, interval, and I want the set. Okay, so this is pretty easy to solve. We got 1/4 x is less than or equal to 3/2, so we'll just multiply both sides by the reciprocal, 4/1. And remember how we multiply, top times top, bottom times bottom, reduce, so we got 4/4 x, or we could have just like canceled those. Got 1x, 12/2, 6. So there's our answer. X is less than or equal to 6. Now you could have canceled the 2 into the 4 and made it 2 and then did 2 times 3 and got 6 that way. That's fine. Do it that way, that's fine. So we look at the graph. And that is a bracket and shaded to the left. Less than, right? Okay, interval notation, that's -infinity. Anytime you got the arrow going forever left, it's going to be -infinity. Anytime you got the arrow going forever right, that'll be a positive infinity in the second position. And now set notation is just, you gotta fancy up the answer a little. It's that answer, it's just you do a squiggly x such that, and then x is less than 6. That's all. That's set notation. And so it's just sort of a fancier math way to write it. -2.3x is less than 6.9. And we're going to do the graph and the interval and the set, all right? So this time I'm going to divide both sides by -2.3. And we're going to have x is greater than, because I'm dividing both sides by a negative, I flip the sign. So that less than becomes a greater than sign. And what is that, -3? All right. Got 0, 1, 2, 3. There's -3. We're looking at a parenthesis and going that way. So there's the graph. Interval notation is -3 to positive infinity, both with parentheses. And then set notation is just squiggly x such that x is greater than -3. All right. Lovely. Let's do page 14, where they're going to throw a little more complicated problem at us. Still just an inequality. So do not be intimidated by large problems. Do not be intimidated by large problems, because we're going to take this and just one step at a time. So first do the distributive property. We see a number with parentheses, a number outside of parentheses. Let's distribute those first. One bite at a time here. We'll put a 1 on that so we remember it's 1x, all right? Very common error to think of that as 0. Okay, so we did the distributive property. I took 7 times x and 7 times negative 2. I took negative 4 times 5 and negative 4 times negative 1x. All right? Now, combine like terms. This is a like term with that. I can put those together. I get 8x minus 14. That greater than sign is still there. This is a like term with that. I can combine those. They're both negative. So negative 12 and negative 20 is negative 32. You can put it first or second. It doesn't matter. I like to write it variable then number. So, all right. Just make sure if you write it the other way, you remember the negative 32 plus 1. All right? So now, move the forward. See, it's 2 little steps later, and then it doesn't look so awful. This initial one, I've had plenty of students over my career say, yeah, I'm out. I'm not doing that. Ooh, that's long. It's the distributive property and combining like terms. And now it's just like the problem that we had in the last page. Good. The x's over to one side. I usually will always left justify x's when I'm working inequalities. It makes it easier to do the graph and easier just in general if you always keep it left justified. So always put the variables on the left side. Don't forget the negative is on that 32. That is a very common error. People cancel that off and they forget about the negative. All right? 4x is greater than, what is that, 18? Negative 18? Okay, yeah. And so now we've got, we're at a crossroads here. I'm going to divide by 4, and since I have to do the graph and the interval notation and the set notation for this, I would prefer to leave it as a decimal because I'm going to have to find it on a graph. Sometimes you got to read the instructions carefully. Sometimes they'll want that as a fraction. If they wanted it as a fraction, we'd probably still want to write it as a mixed number and make it negative 4.5. But since there's no instruction on how to leave it, so I'm going to go with the decimal. And now let's do the graph. Is x is greater than negative 4.5, so 0, 1, 2, 3, 4, 5, there's 4, there's 5. Halfway between negative 4 and negative 5 is negative 4.5. It's a parenthesis and shaded to the right. Interval notation then is negative 4.5 to infinity, right? It's going off to the right. And they both get a parenthesis. Infinity always gets a parenthesis. The number gets one because it's a greater than sign. And then the last thing, set notation is just x such that x is greater than negative 4.5. All right? If you wanted to, you could have did, or even if you reduce it, divide by 2, 9 halves. Those would also be acceptable. But for me, those are good. Like I said, unless it specifically says on the test, they want it in as a mixed number. They want it as an improper fraction. All right? It's about context. If I'm graphing a line, I want it like this because I want the slope as an improper fraction reduced. If I'm talking about, I don't know, bushels of baskets, bushels of apples or something, 4.5. And if I'm talking money, I want 4.5. All right? Okay. So you are having a catered event. You can spend $1,200. Setup fee is $250 plus $15 per person. Find the greatest number of people that can be invited and still stay within the budget. Okay. So usually when we work this, we don't really work it like in the real world. We find the maximum number and kind of that's what sticks in our head. And it's kind of common sense to say, you know, or less. So, but to tie this concept into the real world, we'll do, what is it? So it's $15 per person, so X are the people, plus $250. It's $250 no matter what. If one person shows up or 60 people show up, it's $250 for setup. And that's got to be less than or equal to $1,200. Like I said, in the real world when we're working this, we usually put an equal sign there and just figure out the maximum number. But we're playing with inequalities, so we'll go along with it. 15x less than or equal to 950. And now we divide, and because it's a real world problem, it's not necessarily going to be pretty. And it's not, it's 0.33 forever, right? 63.3. Now, that means less than or equal to 63.333, but we have context here. You can't invite 1/3 of a person. That's not a thing. And so the interpretation then would be the greatest number of people you can invite is 63 people. So now, even if this were 63.999, 63.855, I wouldn't make it 64. Because if you bump it to 64, now you've spent more than your $1,200. But again, this isn't usually how life works because, right, if you did end up inviting 64 people, you'd probably just say, oh, yeah, we went over our budget. It's now $1,215, you know, or $1,438 or whatever it turns out to be. We usually just pay the extra $15 and go on with our lives. So, and not to mention, mathematically, this interpretation means 2 would be an okay number. But if you're doing this, you're going to want more than 2 people there, I'm guessing, or 3 or 4, you know, unless you really want to stay way under that $1,200 budget. So usually we kind of aim for that one. All right, awesome. Next video I do is going to be 2.6.